Hi, my name is Sebastian, and today we want to give you a quick guide of our most recent work on measuring and quantifying feature importance methods. We know that feature importance methods, like GradCam, are widely used to explain a model's decision. However, the way these results are interpreted is sometimes misleading or inconsistent with the user's expectations. Furthermore, methods such as GradCam tend to focus on the most salient feature, where many other class-relevant features may exist. This is why we find the need to ask about the features that become more relevant in the absence of others. Remove and Retrain, or ROR for short, it's a benchmark from 2019 that evaluates feature importance methods by tracking the degradation of a model's accuracy when the input area is being progressively occluded. Surprisingly, instead of a steep and gradual decline in accuracy, this method found that there is almost no deterioration, even after large portions of the input space have been removed, similarly to what happens when removing random parts of an image. We identified two limitations of this approach. First, determining what parts to remove next is based on a single estimation of importance, and won't reflect the raise in importance of other class-relevant features. Moreover, some class-relevant features might be preserved by the mask itself, such as the form of an object or its position, something that was not considered in the original benchmark. This is why we propose ITEROR, a benchmark for evaluating expected properties of feature importance methods, and the way these can be interpreted. ITEROR works as follows. After training a model on a target dataset, we calculate the feature importance of each sample and create a binary mask by using a fixed threshold. Finally, the masked version of the original image gets saved as a new dataset. At this point, a model can be trained on this new dataset, and the cycle starts again, calculating the feature importance of each sample, thresholding, masking, and storing. Notice that, since the masks have been computed independently, we have the chance to study the relationships between them, and what those relationships say about the feature importance method. In particular, we focus on how much overlap there is between masks. To study this overlap, we propose several metrics that convey how overlap behaves for a single sample, what is the total accumulated overlap after all cycles are computed, and a single metric estimate of the expected overlap for a given feature importance method. Finally, we want to measure whether masks themselves are leaking class-relevant features or not. We can easily probe them by training a model directly on the masks. If the model's performance exceeds random chance, we propose a range of alterations to be applied to the mask that minimize information leakage. Thank you so much for watching. Please don't forget to check out the paper for more details on the method and evaluation protocol. If you have any feedback, please get in touch with us.